Shui Li, a planetary scientist at the University of Hawaii at Manoa, is likely to be remembered as having had a significant impact on the direction of human space travel. He oversaw the scientific team that unequivocally discovered water ice in the lunar poles in 2018. Following that finding, efforts were concentrated on sending probes to the lunar South Pole with the goal of ultimately gathering ice for future settlements. Lunar habitation is seen by NASA's Artemis program, which aspires to create a permanent presence on the Moon, as a first step towards future exploration of Mars and other planets. The examination that Li's team conducted into the interactions between the Moon and Earth's magnetotail is described in his most recent publication, which was published in the journal Nature Astronomy. They discovered several unrecognized ties between Earth and the Moon that are awaiting discovery, Li said in an interview, adding that a few significant difficulties now prevent the establishment of prosperous Moon colonies in the future. The three main processes of lunar water creation that have, as far as we are aware, produced the reserves that are now known to exist on the lunar surface. One was the so-called lunar interior degassing, which took place billions of years ago when ancient lunar volcanic activity released internal water. Li stated that the process came to an end about 1 billion years ago when the amount of volcanic activity on the lunar surface drastically decreased. Another process, known as impacting, involves water-rich comets striking the surface of the Moon over thousands of years, leaving water behind. The implantation of solar wind protons into lunar regolith, or soil, is a third step that takes place. Li's most recent investigations into lunar water have been centered on this. It is a procedure that is still going on today, and it is believed to produce water very quickly. The significance of lunar water creation, according to Li, extends beyond only establishing the existence of water that may be utilized for future homes. According to him, water is one of the few elements on the lunar surface that might have preserved information about the genesis and evolution of the Moon. Scientists once thought there was no water on the lunar surface. However, pictures taken by NASA's Clementine lunar mission in 1994 showed that there could be water ice in craters at the lunar South Pole. But it wasn't until 2018 when water on the lunar surface was shown to exist. Li and a group of researchers identified three distinct signs that unequivocally demonstrated the existence of water ice on the lunar surface using information from NASA's Moon Mineralogy Mapper, M3, on board the Indian Space Research Organization's, ISRO, Chandrayaan-1 satellite. Leading space powers from across the globe mobilized and prepared missions to the lunar South Pole as a result of the finding. The region contains greater, more concentrated ice stores, the majority of which are located in shadowed lunar craters, also known as perpetually shadowed regions, PSRs. India accomplished the first successful soft landing on the lunar South Pole in August. Its Chandrayaan-3 project was created to look for large water ice deposits on the lunar surface that may one day be used to support lunar homes for people. NASA intends to deploy people to the lunar South Pole for the first time with its Artemis 3 mission, which is presently scheduled for 2025 or 2026, with the goal of ultimately constructing dwellings that make use of the region's resources. Both China and Russia intend to establish their own colonies using such water ice resources. Despite the fact that Li's research has demonstrated the existence of lunar water ice, he is unsure if there will be sufficient supply. According to Li, the sunlit surface of Luna is thought to contain another 100 million tons of hydroxyl-related chemicals and another 100 million tons of water ice. The major challenge to mine the water ice could be the extremely cold environment he stated. While the extremely low water content on the sunny surface where solar energy is accessible might be the main barrier to collect water,